This is the first identity. The second one is, let's say for example, if we divide sine throughout, what are we going to have? Sine squared x throughout, what are we going to have? So here we want to say that this one and this one, they are going to cancel each other. Then what are we going to have? We're going to have 1. And you know to say that there are trigonometric ratios that you need to know. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent divided by hypotenuse. Tan theta is equal to sine theta divided by cos theta. Or you can say opposite divided by adjacent. We also have other trigonometric ratios that you need to know, which are the reciprocal of these. The first one is cosec. Cosec theta is equal to 1 over sine. It can be also written as cosec theta is equal to hypotenuse divided by opposite. Then the second one, so this is the first one. The second one is secant. Sec theta is equal to 1 over cos. It can be also written as sec theta is equal to, we know to say that cos is equal to adjacent over hypotenuse, so it's hypotenuse divided by adjacent. Then the third one, cotangent. Tangent theta is equal to 1 over tan. We know to say tan is equal to opposite over adjacent. So meaning to say this one can be written as adjacent over opposite, or it can be written as, since we know it can be written as sine over cos. So it is cos theta over sine theta. So that is what we are going to consider. So this one is cos over theta, which means we are going to put cotangent now. Since that we are having a squared, so it's going to be cotangent squared x. And this one is going to be equal to 1 over sine is what? 1 over sine is cosecant. Now we are having a squared, so it's going to be cos x squared x. Second identity. Third identity, let's try to divide throughout by cos squared theta and then see what we are going to have. So here, let's see. So here we are going to have 1. Okay, that is what we are going to have here, 1. But what about this one? Sine over cos is tan, so we are going to have tan squared x, then plus 1, and this is going to be equal to 1 over cos is what? 1 over cos, this one, secant. So it's going to be secant. Okay, let me just do this. Sec or secant squared x. So this is the third identity that you need to know. So all these identities, you need to know them. But there are also applications that you need to know, like this one here. If you have sine squared x plus cos squared x is equal to 1. You can also find what sine squared x is by taking this one to the other side. Then what are we going to have? We're going to have sine squared x being equal to 1 over, or 1 minus cos squared x. This is what we are going to have. Try to take, if you want to find what cos squared x is, you can just take this one to the other side and then see what you're going to have. Going to have cos x, it is going to be equal to 1 minus sine squared x. This one is also very, very important. This one also, tan x squared x plus 1, which is equal to secant squared x. If you take 1 to the other side, what are you going to have? You're going to have tan squared x. So tan squared x is going to be equal to secant squared x minus 1. This is also another way of applying this one. Then the last one, we have cotangent squared x plus 1, which is going to be equal to cosec or cosecant squared x. If you take this one here to the other side, what are you going to have? Cotangent squared x is going to be equal to cosecant squared x is equal to or minus 1. Yeah, this is also another application that you need to know. Now let's try to look at sum of two angles. Sum of two angles. So in talk of sum, you are adding or subtracting two angles. Let me start with the first one, which is for sine. So we need to say that sine. Now here we are adding. Let's say we have two angles, that is a plus b. We are adding angle a and angle b. So what are we going to have? We're going to have a plus or minus b, and this one is going to be equal to. So these identities, they are very, very important to know. So what are we going to have? We're going to have sine a. We're starting with this one here. Then the second one is going to be cos this angle a, which is b. Then plus or minus. Since we have started with sine here, we're going to start with cos here. Cos a. Then sine b. This one is very, very important. Meaning to say here we have two identities. The first one is for positive, the second one is for minus. Let me start. We have a plus b, sine a cos b plus cos a sine b. That is the first one. The second one is sine open bracket minus b is equal to sine a cos b, then minus cos a sine b. So these are the two identities which I was talking about. Just depend on how the question is. Alright, so the second one is going to be for sine. So this is the first one, and the second one is for cos. So cos open bracket, we are adding a plus b or plus or minus b. Now this one is going to be equal to, so for cos is different from sine. Here what you're going to have, you're going to have cos a cos b. That is very, very important to know. Okay, so let me just write it nicely. Then another difference is that here, as you can see here, we have plus or minus, but here what we are going to have, we're going to have minus or plus, so they are going to swap. And this is very, very important to remember, because I can assure you, if you're not going to consider these differences, you're going to make mistakes in terms of when doing the calculations. And then the last part is sine a, and then sine b. So that is it for these two identities. Now the last identity, since here, like I said, each identity, it has two identities. The one for positive throughout, for like the way sine is, the negative throughout. But for this one here, what are we going to have? If we use plus a, what are we going to have? Cos open bracket a plus b, and this one is going to be equal to cos a cos b. Now instead of saying plus, we are going to say minus. So as you can see here, we are having positive throughout, minus throughout. But for this one here, if we use positive here we're going to use a minus. So those are the differences that we need to consider. Alright, so that is minus sine a sine b. And then the last one, we have cos open bracket a minus b. And then this one is going to be equal to cos a cos b. Now instead of saying minus, what are we going to use? We are going to use positive, and this one is going to be sine a sine b. So these are the two identities for cos, and they are very, very important to know. Let's try to look at tan. So we know to say that tan is equal to what? If we have tan theta, this one is going to be equal to sine theta divided by what? Cos theta. But what we are going to do here, we're going to say tan open bracket a plus or minus b, and this one is going to be good. What is sine? Sine is this one here. Alright, so I'm going to say sine open bracket a plus or minus b. This is what we have. But what about cos? Cos is this one here. So I'm going to say O over, we have cos open bracket a plus or minus b. Actually, this is what we have, but let me just try to do this. Okay, so what we are going to do here is we know to say that sine is which one? Combination of these two, isn't it? When you consider the plus or minus, it's a combination of this. And for tan, it's just this one. This is a combination of these two. So let me write it here. We know to say that sine is sine A cos B plus or minus cos A, then sine B, then O over. What is cos? Cos is cos A cos B, then here it is minus or plus, not plus or minus, plus or minus, no, it is minus or plus, then sine A sine B. So that is how you're supposed to do this one. But what I'm going to do here is let me just try to simplify our work here. So I know to say that I can divide throughout by cos A cos B. The reason why is I know to say that here I'm having cos B, here I'm having cos A, so at least cos is common, right? Yes. Okay, so if I divide, what am I going to have? So let me just erase this part here. Let's take this one here up. Alright, so this is what we have, isn't it? Now what I'm going to do here, if I divide throughout or I multiply throughout by 1 over cos A cos B, that is for the top, then for the down part 1 over cos A cos B, what am I going to have? So definitely, let me just do this. Okay, so this is what we are going to have. So for the first part, what are we going to have? We are going to have sine A cos B, then divided by cos A cos B. Then here you can say plus or minus. Then if I multiply here, what are we going to have? We're going to have cos A sine B divided by cos A cos B, then O over. So O over this one here. Then for the down part, you can say we have 1 multiplied by this one here. What are we going to have? We're going to have cos A cos B divided by the same thing, which is cos A cos B, then minus or plus. So these signs are very, very important to remember. Then 1 multiplied by sine A sine B, we're going to get sine A sine B divided by cos A cos B. So this is what we have. Now what I'm going to do here is let me try to cancel what is common and do the assumption for what is not going to be common. So as we can see here, this one and this one, they can cancel each other, meaning we are going to remain with this one and this one. Then here, this one and this one, they can cancel each other. So these, they can cancel each other, meaning here, what are we going to have? We're going to have 1. So let me just rewrite. Okay, let me take this one. So here we have sine A cos divided by cos A. If you remember, sine theta divided by cos theta is equal to what? Is equal to tan theta. So here we are going to have tan A. Then the signs plus or minus, these have been cancelled. Sine B divided by cos B, the same as this one. So we are going to have tan B. Remember, the angles here, they are represented by the letters A and B. Then divided by, on the down part here we have 1 minus or plus. Here we have sine A divided by cos A, which is same as the tan A. Here we have sine B divided by cos B, which is same as what? Tan B. So remember, even here we have two identities, the one which goes for a positive and the one which goes for a minus. So writing this, we can say we have tan, open bracket, A plus B, and this one is going to be equal to tan A plus or minus tan B, then divided by 1 minus or plus tan A, then we also have tan B. So this is what we have, but let me just try to separate these. What I'm going to do here, let me just like the same way. We have tan A plus minus B. This one is going to be equal to tan A plus or minus tan B, then divided by 1 minus or plus tan A, then we also have tan B. So here we have two identities. The first one is for positive, tan is equal to A plus B. I've started with a plus. So what are we going to have? We're going to have tan A, then here on top we're going to say plus, and then we're going to say tan B, then minus. What sign are we having on top? We're having a minus. So tan A, tan B. So this is the first identity for tan. The second one is when we're going to use a minus, and then see what we're going to have. If we use a minus, what are we going to have? We're going to have tan A minus tan B, then divided by 1. If we use a minus here we're going to use a positive. So it's going to be tan A, tan B. So let me just give you examples on how you can apply these identities so that we can appreciate more. You need to find the exact value. So let me just say find the exact value. You need to find the exact value for the following, or of each of the following. So the first one, which is A, let's have cos. And then let's say we have 60 degrees plus, let's say 45 degrees. We need to find the actual value. Then also have B, which is tan 15. Then also have C, which is sine 465. Then D, let's say we have cos 105 degrees. So let's try to answer this, but for you to answer these questions, at least you need to have ideas on special angles. But don't worry, I'm going to explain as I'm answering. So let's start with this one here. I think this one is just very simple. What is the identity for cos? Mind you need to remember that here they are using positive, so you need to use the identity for positive. So cos A plus B, this one is going to be equal to cos A cos B. Then remember, if you are using a positive here, meaning here you need to put a minus. That is very, very important. You're not supposed to forget that one. So let's put now the values. So meaning to say the value of the angle A, it is 60 degrees. Then the angle B, it is 45. So the first one we're going to have cos 60 degrees. The second one we're going to have cos 45, then minus. So we have sine 60 degrees, then also have sine 45. Now for us to work out this, let me just draw a triangle. Okay, and this one is going to make sense. Okay, so that is our triangle. So here we are going to have 30 degrees, then here we are going to have 60 degrees. So here it is 2, then here root of 3, then here we have 1. Then the second triangle for 45, right, so that is what we are going to have. Let me do this. Of course this is 90. So if you say a right angle triangle add up to 180, so if you add, you're going to get 180. So in here that is 90. So here I'm going to have 45. Even here I'm going to have 45. Now for this one here we're having 1, here, even here we're having 1. Then here root of 2. That is one thing that you need to know. So let's start with cos. What is cos 60? Cos, we want to say that cos is equal to what? Cos theta, adjacent of hypotenuse. So the hypotenuse here, it is 2. And then the adjacent here is what? It is 1. So we have adjacent divided by hypotenuse, which is 2. Let's come to cos 45. Cos 45, adjacent is 1, hypotenuse is root of 2. So 1 over root of 2. So a side can't be a denominator. So to eliminate a side, to eliminate a side as a denominator, what I'm supposed to do is multiply by the conjugate. So we have 1 divided by root of 2. So you multiply by root of 2, then you numerator and the denominator. Then you're going to have root of 2 divided by 2, because you know to say that root of 2 multiplied by root of 2, it is 2. So this is what we're going to have inside. So let me just do this. Okay, so even here, so here we know to say that that is 1 over 2. Then here we're going to have root of 2 divided by 2, then minus. What is sine 60? We know to say that sine theta is equal to opposite of hypotenuse. So the opposite here is root of 3, then the hypotenuse is 2. So we have root of 3 divided by 2. Then what is sine 45? Sine 45, again opposite divided by hypotenuse. So this one is same as like this one here. So when you multiply, you're going to get root of 2 divided by 2. Alright, so this is what we are going to have. 1 multiplied by root of 2, that is root of 2. 2 multiplied by 2, that is 4. Then minus root of 3 multiplied by root of 2, it is root of 6. Then divided by 4. Since we know that 4 and 4 is common, so you can just say root of 2 minus root of 6. Then divided by 4. Then from there, you are done. So this one is the first part, or the first question. we have answered that one. So let's try to also to answer the second one. All right, coming.